Namaste dosto. Imagine standing outside and trying to figure out how tall a distant tree or a tower is without climbing it or measuring it directly. Sounds tricky, right? But here's the magic. Trigonometry has got our back. Today, we're diving into heights and distances, a super useful application of trig that helps us measure heights and distances just by knowing angles and a little bit of math. So, what's the idea? When you look at an object, say a tower, the line between your eye and the top of that tower forms an angle with the horizontal ground level. This angle, together with some measurements we can take, creates a right-angled triangle. By using the trigonometric ratio sine, cosine, or tangent, that is, sin theta, cos theta, or tan theta, we can figure out the unknown sides like the height or distance. The line of sight, which is basically your visual line to the object, could be straight ahead, meaning 0 degrees, or it could slope upwards or downwards, called angles of elevation or depression. These angles help form the triangles we need. In real life, this method is extremely handy. For example, when you want to find out how high a tower is, how wide a river is, or how far away an approaching vehicle might be. Moving forward, let's clearly understand two important angles: angle of elevation and angle of depression, terms you'll hear often in these problems. Picture yourself standing on a flat ground, looking up at a tall building. The angle your line of sight makes with the horizontal ground as you look upward is called the angle of elevation. The key point here: your line of sight is above the horizontal level. Now flip the scene. Imagine you stand atop a cliff and look down at a boat in the sea. The angle your line of sight makes downward from the horizontal line is called the angle of depression. Your line of sight is below horizontal. In both cases, we can form right-angled triangles. These triangles are perfect for using the tangent ratio, which we recall is the ratio of the side opposite the angle to the side adjacent. Or verbally, tan theta equals opposite side divided by adjacent side. There's a neat geometric fact here too. When your line of sight and the horizontal are parallel lines, the angle of elevation and the angle of depression are actually equal as alternate interior angles. This equality makes solving these triangles easier and more accurate. Imagining diagrams with labeled angles for elevation and depression. So when you see these angles, remember how the line of sight behaves, above or below horizontal, and you're already halfway through the problem. Now, let's talk about how exactly we apply tangent in real height calculations. Suppose you know how far you are standing from the base of a tower, and you measure the angle of elevation to the top of that tower. Perfect! This is where the tangent formula comes alive. We use the formula: tangent of theta equals the height of the object divided by the horizontal distance from the base. In simple words, tan theta equals height over distance. Rearranging this to find the height, we get height equals distance multiplied by tangent of theta. That means once you calculate or know tan theta, you multiply it by your distance from the tower to get the tower's height. One very important note: to use this correctly, the triangle must be right-angled, which means the ground or the path where you stand should be level, horizontal. This method is brilliant for finding the height of places or objects that are inaccessible, like tall mountains, poles, or towers, where direct measurement is impossible or unsafe. With mental image of triangle showing base distance d, height h, and angle theta. Isn't it amazing how such a simple ratio can give us the height just from a ground measurement and angle? Excellent beta, you're getting it. Let's put theory into practice with a classic example. Imagine a tower and you stand 50 meters away from its base. From this point, you observe the top of the tower at an angle of elevation of 30 degrees. The question: what is the height of this tower? Picture the situation as a right triangle where the horizontal side is 50 meters, the height of the tower is what we want to find, and the angle at your point of observation is 30 degrees. We use the formula: tangent 30 degrees equals height divided by 50. Repeating, tan 30 degrees equals height over 50. We know tan 30 degrees is 1 over square root of 3. So, 1 over root 3 equals height divided by 50. Multiplying both sides by 50, Height equals 50 times 1 over root 3, which simplifies to 50 divided by root 3. To simplify further, we rationalize the denominator, multiplying numerator and denominator by root 3 to get height equals 50 root 3 divided by 3. Calculating this approximately gives us 28.87 meters. So, shabash. The tower's height is roughly 28.87 meters. Visualizing the triangle labeled with 50 meters base, 30 degrees angle, and unknown height h, this classic use of tangent solves real-world height problems simply and accurately. We have seen how single angle and distance help, but sometimes we get to observe from two different points. Imagine you make two observations of the same tower from 2 points on a straight line. The angles of elevation differ, call them alpha and beta, but height remains the same. This situation gives us two tangent equations, tan alpha equals height over distance x and tan beta equals height over distance x plus d, where d is the known distance between the two observation points. By solving these two equations together, we can eliminate one unknown and find the height or distances precisely. This method is super useful when the tower or object is hard to measure directly, and it also improves accuracy because two observations cross-check the results. Imagining double right triangles with shared vertical side but different bases, algebra here is your friend. Equating and manipulating the two tangent expressions helps find both height and distance variables. Let's solve a practical case of those multiple observations. You observe the top of a tower at 60 degrees elevation from one point and at 30 degrees from another point 50 meters further away along a straight line. Goal: find the tower's height. Define the horizontal distance to the first point as x meters. So, from the first point, tan 60 degrees equals height h over x. From the second point, tan 30 degrees equals height h over x plus 50. Recall, tan 60 degrees is root 3, and tan 30 degrees is 1 over root 3. First equation, root 3 equals h divided by x, so h equals x times root 3. Second equation, 1 over root 3 equals h divided by x plus 50, so h equals x plus 50 divided by root 3. Now, since h is the same, equate the two expressions. X times root 3 equals x plus 50 divided by root 3. Multiply both sides by root 3. 3 times x equals x plus 50. Bring x to left side. 3x minus x equals 50. 2x equals 50. X equals 25. Time for a quick recap of what we've learned. First, the fundamental formula is tangent theta equals height divided by distance from object. Second, to find the angle given height and distance, use inverse tangent. Theta equals arctangent of height over distance. Third, when two angles are involved, we can calculate height h using the formula. Height equals d times tangent alpha times tangent beta divided by tangent beta minus tangent alpha. Key ideas to remember. Trigonometry lets us measure heights and distances indirectly through angles and known measurements. Always model your problem as a right-angled triangle, carefully marking known and unknown paths. Drawing accurate diagrams showing where angles and sides go saves time and errors. And when you have multiple observations, use algebraic methods to eliminate unknowns and improve accuracy. These tools are essential for everything from surveying land, navigation, to everyday problem solving. So dosto, keep practicing. This knowledge will surely boost your math skills and help you crack tricky exam questions. Substitute back to find height h. H equals 25 times root 3, which is approximately 43.3 meters. Excellent. The height of the tower is roughly 43.3 meters. Time for a quick recap of what we've learned. First, the fundamental formula is tangent theta equals height divided by distance from object. Second, to find the angle given height and distance, use inverse tangent. Theta equals arctangent of height over distance. Third, when two angles are involved, we can calculate height h using the formula. Height equals d times tangent alpha times tangent beta divided by tangent beta minus tangent alpha. Key ideas to remember. Trigonometry lets us measure heights and distances indirectly through angles and known measurements. Always model your problem as a right-angled triangle, carefully marking known and unknown paths. Drawing accurate diagrams showing where angles and sides go saves time and errors. And when you have multiple observations, use algebraic methods to eliminate unknowns and improve accuracy. These tools are essential for everything from surveying land, navigation, to everyday problem solving. So, dosto, keep practicing. This knowledge will surely boost your math skills and help you crack tricky exam questions.